This is the electric motor experiment by Madeline, Natalie, and Michaela.
Our experiment was testing how the number of magnets would affect the speed of the motor. The magnetic fields and velocity are directly related, which means that adding more magnets would create a larger magnetic field, which would result in a higher velocity. The first model on the left shows the current flowing in one direction, so using the right-hand rule, the field is going into the page. Then when you use the right-hand rule on the bottom of the ring, the field is going out of the page. This then gets flipped when the ring is turned 180 degrees. For the next model to the right, it shows a system schema. The magnet is in contact with the wire, and the wire is in contact with the coil. From there, the coil and the battery are connected through a magnetic field.
This is our experimental design. The coil moves as a result of the voltage from the battery in the strip coil. We only strip the coil on one side. This is to control the current. Incorrect stripping will cause the coil to rock back and forth instead of completing full rotations. The stripped side allows the current to flow through it, and the non-stripped current does not. In this video, we show an example of where the wire was not stripped and the coil changes the way it rotates. Voltage was constant throughout all the trials. We used 4 batteries each time. To change the strength of the magnetic field, we increased the number of magnets between the trials, measured the number of revolutions of the coil during 5-minute intervals for each number of magnets, and our hypothesis was that more magnets will create a larger magnetic field and cause more revolutions, which demonstrate higher velocity.
To count the revolutions, we took slow motion videos of the motor. We took 3 5-second videos for each number of magnets. The average revolutions for each number of magnets were as follows: about 44 revolutions for 9 magnets, 43 revolutions for 7 magnets, and 33 revolutions for 5 magnets. We found that 9 magnets had the largest number of revolutions and 5 magnets had the least. So, more magnets created a larger magnetic field. The magnetic field and velocity are directly proportional, so having more magnets caused more revolutions. The reason that the magnetic field increases is because each individual magnet has its own magnetic field, but when it is combined with another magnet, their magnetic fields join to become one larger and stronger magnetic field.
The toy motor is a great model for this experiment because both motors are generated by electric current and magnetic field. Also, the type of current used is DC current.
Some possible errors in our experiment include that the batteries could have lost some voltage over time, we could have miscounted the number of revolutions, the wires could have moved within our setup, changing the friction and ability to rotate, and too much of our wire could have been stripped, which would cause the wire not to spin as fast due to resistance or start spinning in the opposite direction.
Thanks for watching!